Hi there, future leaders of artificial intelligence. Welcome to Anodium, education that enlightens. In this video series, we will be covering some prerequisites of learning artificial intelligence. Artificial intelligence is implemented on digital computers, and digital computers are good at computing, that is counting. So let's first find out how computers count. Let's start with how we humans count. We are used to counting with the decimal system that comprises of 10 numerals, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, and a very special numeral called 0, which means no count. So let us find out how we count through our decimal number system. When we have no apples, we say we have 0 apples. When we have 1 apple, we denote it like this. For 2 apples, 3 apples, and up to 9 apples, we denote it by the numerals just like this. What happens when we have one more apple, that is the 10th apple? We represent it by 2 digits, that is 1 in the left hand digit and a 0 in the right hand digit. This way, we represent 11, 12 and up to 1, 6, 1, 7, 1, 8 and 1, 9 apples. So in the first row, we are actually having an invisible 0 in all these first digits. In this way, with 2 digits, we can count up to 20, 21, 23, up to 28, 29 and up to 98 and 99 apples. So after the 99th apple, when we have one more apple, what do? We denote it like this, that is by 3 digits. 1 in the first digit and then 0 and 0 in the second and third digit respectively. So all this while we were having a leading invisible 0 in these first digits just like this up to here. In this way, with 3 digits and these 10 numerals, we can represent up to 101, 102 and up to 109, 200 up to 998 and 999 apples. What happens when we have the next apple? That is, how do we count the 1000th apple? We now move to the 4th digit and represent it by 1 followed by 3 zeros. In this way, we can represent up to infinite number of apples with just 10 numerals, that is 0 to 9. Similarly, with just these 10 numerals, we can also represent up to minus infinity and any other real or fractional numbers. Because this video is aimed at learning AI, I am not going through the details of counting negative apples or fractional apples. Now, for the sake of illustration, pardon me to be a bit rude and take away all the numerals of the number system after 3. So we are now left with 4 numerals, that is 0, 1, 2 and 3. Can we still count everything with just 4 numerals? Let's try out. When we have no apples, we can again say that we have 0 apples. We can denote 1 apple like this, 2 apples and 3 apples. Now we cannot write the numeral 4 because we do not have numerals beyond 0, 1, 2 and 3. We do not have this numeral 4 anymore. How do we denote the 4th apple? We denote it like this. With 2 digits, the numeral 1 in the first digit and the numeral 0 in the second digit. As you might agree that we were having a leading 0 in the first row, and this row is the row of leading ones, and this is how by 1, 1 we denote the 5th apple, and this is how we denote the 6th apple by 1, 2 and the 7th apple by 1, 3 in the number system of base 4. Similarly, we denote the 8th apple by 2, 0, 9th apple by 2, 1 and up to the 15th apple by 3, 3. How do we denote the 16th apple? when we are finished with all our numerals and cannot write 4 in either the first digit or the second digit. We now use 3 digits to denote the 16th apple, 1 in the first digit and 0 in the second and the third digits. Considering 3-digit numbers, all these numbers must have been having a leading 0 in front of all of them. And proceeding in this way, we can now write the 17th apple like this, the 18th apple like this, and so on up to the 31st apple as 1, 3 and 3, and keep proceeding like 200, 201, 202 and up to 233, 300, 301, 302, 303 and up to 330, 331, 332 and 333 for 47th apple when we are finished with numerals for 3-digit numbers of base 4. We then start the 4-digit numbers and denote it with 1,000,000, but this actually means 48 for our decimal number system. Therefore, proceeding in this way, we can represent all numbers up to infinity or even up to minus infinity, or all real numbers with the number system of base 4 also. The next type of number system that we are going to discuss now is of base 16. That is, it will not only have numerals of 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9, but also it will have 6 more numerals denoted by A, B, C, D, E and F. Let us see how we can denote all numbers, this time with 16 numerals. As before, when we have no apples, we say we have 0 apples. And we start counting 1 apple like this, 2 apples, 3 apples and up to 9 apples like this. For the next few apples, we will denote the 10th apple by an A and keep denoting the next apples by B, C, D, E and F as the 15th apple. Once we are finished with all the numerals for the first digit, we start expressing with 2 digits and we denote the 16th apple as 10. In this way, we count up to the 31st apple as 1F. That implies when we were counting apples in the first row, they were all having an invisible 0 leading in front. And now with 2 digits, we can represent up to 9091 and up to 98 and 99 apples, and then 9A, 9B, 9C, 9D, 9E and 9F apples. And then we go to A0, A1 and up to AF apples. And similarly, proceed up to F0, F1, F2, F3 and up to FD, FE and FF apples. And now that we are finished counting apples with 2 digits, the next apple we will count by 3 digits and as 100. And the 3-digit apples we will be counting up to FF and F. And in this way, using 16 numerals, that is in case of our hexadecimal number system, we can also count from minus infinity to plus infinity and all the real or fractional numbers as well. Binary system is a special number system that has got only 2 numerals, 1 and 0. which is used to represent two possible states of electronic circuits that are off and on, and hence used by digital computers for all computing purposes. Now this particular video is getting too long, so we will continue our binary number system of digital computers in the next video. Please stay tuned. If you found this video informative, do give us a like. Do not forget to subscribe and share. Thanks again from anodium.com, education that enlightens.